Science Beetle.
Welcome back, students. In this video, I want to go ahead and focus on stoichiometry. Specifically, what I want to focus on is identifying the limiting reactant of two reactants that are involved in a chemical reaction, and we want to know which one runs out first. So here we've got a balanced chemical reaction. It's a sample problem, and we are given the following information. We're told that we have 2.5 moles of each of the reactants in this particular reaction, and we are asked to identify what is the limiting reactant. So if we look at some of the important parts here, typically what I would recommend you do is underline general information that's provided. So we got 2.5 moles of each reactant. So typically I will go ahead in here and identify that we've got 2.5 moles of this particular compound, and we've got 2.5 moles of the other compound. Now, what this question is really asking is which compound runs out first? But the way that you have to do this is you actually have to run a test. The test we're ultimately going to run is we're going to ask to essentially figure out the difference between the amount that we have at the start, and we're going to subtract the amount that we actually need. And we're going to get two possible outcomes. We're either going to get a positive value or we're going to get a negative value. If this difference between the have and the need is positive, this essentially going to tell us that we have a excess amount. Okay. However, if the amount is negative, then this is going to tell us that that particular compound is going to be limiting. And so this is going to be very helpful for us. Okay. So overall, let's go ahead and figure this out. Let's go ahead and get this out there. And let's move this equation over here to the side. And let's put this right here so we have a reference for what we've got. And let's go ahead and set this up. So we're going to begin with what is given. We're provided 2.5. And generally what I had shared before is if you look at the coefficients here of both of these reactants, typically, not always, a very high percentage of the time, you can look at the higher coefficient and that will tell you which is a limiting reactant. Now there are instances where this is not entirely accurate. So in the next video, I'll show you how to do this with mass. But for this video, let's assume we use this assumptive process. So what we're going to do at this point is we're going to take the amount that is associated with the bigger coefficient. So in this particular case, the bigger coefficient is going to be the 3. Now the CS2 has a 1, so we're going to take the 3 and say, okay, well, if this is 3, then that means that this particular compound, Cl2, is more than likely going to run out first because we need more of it to start. So with that in mind, what we're going to do is we're going to set this up with the starting amount of that particular limiting reactant. Since we're going with chlorine, we're going to take this starting amount, 2.5, and all we're asking literally is, if I start off with 2.5 moles of chlorine, how much of the other compound do I really need? I've already got the starting amount of the other compound, so what we're going to do is calculate how much we need, and then we're going to use this test that we've set up over here on the right to tell us if we have excess or if we have a limiting reactant on our hands. So let's go ahead and set this up. So the thing we're going to use the 2.5, so we're going to say 2.5 moles of the limiting reactant that we think is the limiting reactant, and that'll be the Cl2. And now we're going to ask, how many moles of the other compound are we going to need? And so in this case here, we're going to look at the coefficients, and we're going to say, well, the ratio between the chlorine is 3 and 1 of the CS2. So for every 3 moles of CO2 that are used, 1 mole of CS2 is going to be used. And so we can do that setup here in the next step. Now, take a look at the numerator here. We've got moles of chlorine. So that means in order for this unit to cancel, we need to place it in the denominator. So in the denominator, what we're going to do is we're going to place here moles of CO2, and it's going to be related to a certain amount of moles of CS2. Now the coefficients here, if we look at the balanced reaction, the Cl2 has a coefficient of 3 and the CS2 has a coefficient of 1. Now let's go ahead and cancel the items that we can cancel. So we can cancel the moles of Cl2 with the moles of CO2. That leaves us with the moles of the CS2. That actually is what we're looking for. So we have enough information now to stop. We don't have to set up anymore. We'll put an equal sign here and then we'll multiply across. When we take 2.5 and we multiply it times 1 in the numerator, we're going to get 2.5, and the unit that remains is moles of CS2. In the denominator, we're going to get a 3, so let's go ahead and put the 3 here. And then if we go ahead and plug this into the calculator, take 2.5 and divide it by 3, you're going to end up with the following value: 0.833 repeating. And this is going to be moles of CS2, and this is going to be the amount that we need. Now, we already have a starting amount here of the other compound. We've got 2.5 to begin with. 0.833 is significantly lower than 2.5, so that's actually going to give us a positive value. But so that we can see it done, let's go ahead and show it here. So let's move this up a little bit here, and so we'll do that. Now we've got a little bit more space. And now what we can do here is let's set up the test. So here is the test. Let's go ahead and put it down. So the test is going to be looking at the amount that we have of that compound, which is CS2. So the amount that we have of the CS2, and this amount was given to us at the very beginning. We have 2.5 moles. And we're going to compare that to the amount that we need of CS2. And this amount here is 0.833, and we are going to be asked to take the difference. So we're going to subtract these two values here. When we do that, the value that we get here is a positive 1.66 repeating. This is going to be moles of CS2. Now, since we have a positive value, this is going to be in excess. Now, excess means that we have plenty of this compound. It's not going to run out. And since there's only two of these compounds, let's move this stuff here, move it down a little bit. So notice over here at the very top left corner, there's only two compounds. And what we've just determined is that the CS2 has plenty of leftover. So if this compound is excess, that means that the other compound actually is going to run out first. And so Cl2 in this particular case is the limiting. So what we'll do here is we're going to go ahead and make this known very clearly at the bottom. So if the CS2 is excess, therefore the Cl2 is limiting. Okay, and that would be the answer for this particular problem. So let me go ahead and zoom out, and then you can see the entire workup here for this problem. So that's the way you identify the limiting reactant using stoichiometry. Now what I want to do here in the next video is I'll show you how to do this using the mass relationship between these two compounds and the coefficients. So keep watching, keep learning, and we'll see you in the next video.